Thank you all for attending the first annual undergraduate projects and research. Super exciting for us. Mara Honenberger, our lead researcher and associate professor here at Salt Lake City, will not be presenting. My name is Shane Schmidt, and with fellow undergraduate Talon Roberts, we'll be looking at near to far, an analysis of dust transportation across spatial scales in the Great Basin, USA. So, when we think about dust transportation in the Great Basin, we can break it down into four key elements. The first being erodible source areas. Do we have somewhere where dust can be produced? Is there sufficient winds to loft the dust? And are there transport pathways where the dust can travel for long distances? And this directly affects the Wasatch Front air quality. Among events, there is high variability with source areas and direction. We can get dust from all over the Western Basin region. So if we look at what that means, what is the Western Basin region? It's essentially this right here, the high western desert. It's bordered here on the east by the Wasatch Mountains, and we see the Great Salt Lake as one of the high population areas, as well as sources called playas, which is essentially dry lake beds. And so here on the west side, it's bordered by the Sierra Nevada range. Reno, Las Vegas, Salt Lake, all being high population areas that are affected by this. So if we zoom into our specific area of interest, this is going to be the Great Salt Lake Basin. Here we see our high population area, the Wasatch Front, with Salt Lake City being the highest populated city of that. We also see the Great Salt Lake, which is a source area for most of this dust, and as it dries up, we have more exposed lake bed, giving more area to the Great Salt Lake Desert. So one of the reasons that we are seeing more dust events as we progress is we've been in extreme or exceptional drought for the last several years with no end in sight. This just causes a lot more source areas, a lot more dry lake beds, a lot more available dust to be lofted. So for our research specifically, we looked at three events. The first being February 5th. At 1800 UTC, a cold front moved across the Great Basin region. Lofting wind gusts got it into the 30 to 45 mile an hour range, and dust emission happened in the northwest of the Great Salt Lake. This air quality degraded and created an event which would be seen as muddy snow, if anyone remembers. The second one we looked at was March 6th, and around the same time, 1800 UTC, another cold front moved across the Basin region. In this event, wind gusts only got to be 20 to 40 miles, which is still enough to loft dust. This one had multiple emission areas across the region, and the air quality degraded to 20 to 50 micrograms per meter cubed. The third is April 5th, around 1600 UTC. Same cold front moves across the Great Basin region, wind gusts 20 to 50 miles per hour. And so emission sources for this one are in the Sierra Nevada range. And this one had higher variability in the air quality, with it degrading to 30 to 170 micrograms per meter cubed. Hand this over to Talon.
All right, so again, we're looking at one of the erodible source areas. This is in the Great Salt Lake Desert, right next to the Great Salt Lake. This was that February 5th day that caused the muddy snow event. And as you can see in the circle, that's the dust storm, so it's quite big. And this is another image from that day. And if you look to the northern shoreline of the Great Salt Lake, you can also see there's a lot of dust activity, and this one looks a little more spread out, and the last one is taken a little later, I believe. But yeah, as you can see, it's quite big. And this was the dust event from March 6th, and this one actually started clear out in the Sierra Nevadas in Nevada, and traveled all the way across into Utah, and those arrows kind of point out that big dust plume. And then circled is the Great Salt Lake. So this was also a pretty spread out event. And then again, to get a dust storm, you need some pretty high wind speeds. And we see later in the evening, we see an increase from between 20 and 40 mile per hour winds and gusts that reached up to 50 miles per hour. And for this event, it was on April 5th, we had wind direction shift between west and northwest. And then here's that muddy snow event for February 5th again. Later in the evening, wind speeds were at 20 to 35 miles an hour, and with wind gusts up to 30 to 45 miles per hour. And this one traveled mostly, or was mostly northwest. And the graphs in these, the red lines and the green dots are showing the wind speed. And this is a map of winds in the higher atmosphere. And if you look at Utah, there's a big highlighted yellow section in there. And the closer to red you get, the higher the wind speed. And if you're looking at Utah, you can tell this has some pretty high wind speed. And this one is for that March 6th event that had the dust plume traveling all the way from Nevada.
So here we're going to watch a short video of transport pathways. This is taken from GOES 16 satellite imagery. It's going to be showing RGB values with pink being dust. Oh, maybe not.
All right,
maybe.
Oh.
Yeah.
There we go. It's really short too.
So here we see the event on February 5th with our source area being just northwest of the Great Salt Lake. Those pink plumes, that is all dust that is lofted into the atmosphere. So now we can... Lake down.
Yep.
So here we're going to be looking at some stilt imagery. This is essentially showing the source areas of dust for different events or particles for different events. So we see here on that March 6th event that originated out of the Sierra Nevada range that a lot of the dust actually is coming up from the southwest and being lofted. And for this April 5th event, we can see that most of that dust is originating near the Sierra Nevadas in California, actually. And then as the winds get stronger closer to Salt Lake, more particles are then lofted. So this is salometer data. It's essentially looking at your elevation and where particles are. Here in the red, we're going to see where we have high concentrations of particles, and you can actually see as time moves on for this event exactly when the particles are lofted right here in this trough here where the red exists.
All right, and this is from that muddy snow dust event that we were talking about before. This car is totally covered in mud, and as you can see in the image to the right, the snow is just muddy and it's everywhere. Kind of gross. And so in particular, we were looking at PM 2.5 data, that's the particle size for the dust, and to give you a perspective on how small that is, PM10 is about the size of a strand of hair, and PM2.5 is 3 to 4 times smaller than that. So really small particles, and typically air quality is considered bad when we have 35 micrograms per meter cubed in the atmosphere. And when we look at this graph, we can see for the February 5th day, we had a station that read almost 300 PM 2.5. So that was really high. And then in total, 11 stations throughout the Salt Lake Valley had levels above 35. So this was a pretty big dust event, and many were close to 100 as well. So, and then similar story for this one. This event actually had 14 stations throughout the Salt Lake Valley that had readings above 35 micrograms per meter cubed. And so this one is a little bit more spread out, not as didn't have as high as a reading, but still a pretty intense storm. So to summarize, we have a lot of variety in the source areas. Some are really small events that are, only about a kilometer wide, and then some are up to hundreds of kilometers. Especially when you look at the event that happened in the Sierra Nevadas. And we need sufficient winds to loft dust, and typically the events were mostly caused by postfrontal and prefrontal events. And our transport pathways mostly came from the southwest, west, and northwest. And there was also a lot of variety in impact. Some were really low, small events, and some were really big, high-impact events. And that wraps it up. So thank you, guys. Any questions? Yeah, I don't have. So, were you meaning this one or the wind data?
Yeah, this one. So,
Okay.
Are those really high mountains, are those closer to the lake bed,
So we found that the one that has consistently higher readings, it has to do with how often it's taking the readings. Some of them only take readings every hour. I believe that one is Hawthorne Academy. It's one of the oldest reading sensors, and it records every couple of minutes. And so it gives you very accurate data. Any other questions?
With the two graphs you had, they were showing the rate of movement.
The the stilt imagery?
Yeah, that. Is it, and on the one on the left, is it coming from that point in Utah, or?
Yeah, so this is showing where the particles are sourced from. So it's going to be, that's where it's coming from in probability.
And then on the right one, you said it's coming from the Sierra Nevada.
Yeah, so you'll see a lot of it's starting in the Sierra Nevadas, and then actually as it gets closer, because the winds become stronger, they went from 20 to 50 miles per hour. You also see dust being lofted really close to the Great Salt, or to Salt Lake as well.
Is that coming from Salt Lake as well then?
Yeah, so that would be considered a mixed storm where we have source areas both in the Sierra Nevada and close to home.
Thank you.